welcome to another video on organic chemistry. So today we are going to learn about a new family, and this family is very reactive. They react with most things that we add to them because they are an unsaturated molecule. So remember we talked about an alkane that is saturated because all its bonds are taken. This one is a bit different because it has a secret bond that's hiding there that could potentially open up and grab anything that you add to it. So this is called an alkene group, and the alkene group we can identify by looking at a double bond. If we see a double bond, we know it's an alkene, and its surname will be -ene. And then the number where of the carbon where the double bond exists. So for instance, if we have one that looks like this, 3, we'll go 4, and we have a double bond there. It's not a butane molecule anymore because it kind of looks like a butane, an alkane, but because we know these are double bond, it can't be, so it's an alkene. So this is now called but2ene because we need to say where the double bond is in the molecule. So you can't just say butene because it could be on the first bond between the first and the second, so but1ene, or but2ene because it's on the second carbon. So 1, 2, 3, 4. Okay, but2ene. Properties of alkenes are pretty similar to the ones of alkanes. So the higher, the bigger the molecule, the stronger the intermolecular forces between the atoms. So the boiling points and melting points will increase with size, but overall they have quite a low melting and boiling point because there's no specific strong forces between those. Another thing is polarity. So remember, it's because there's no stronger atom or electronegative atom in this chain of carbons. It doesn't have a positive and negative ends, so it's a non-polar molecule. And because non-polar molecules don't dissolve in polar water, it won't. It's insoluble in water. So we've got our melting, boiling points, and it's insoluble in water. Okay, so unsaturated molecule. So an unsaturated molecule, remember we said it has a bond that could potentially open. So, which means that whatever we give it, it could react with. So if we add some hydrogen gas to it, what's going to happen? So if you look at those bonds, the double bond, it resembles two. So both carbons have hands that's locking in. So that is one bond. And then another one. So then each carbon will let go of the bond and then grab onto whatever I give them. So the first one, that two H's, each carbon will grab onto an H. And then if that happens, what do we have left? Well, what does it form? It forms an alkane because this carbon will have one H and the other carbon will have the other H. So that forms an alkane. Okay, so if we have an alkene and we add H2 to it, it forms an alkane. If we add bromine water to it, and again this is like the alkane, this is a test of bromine for an alkene as well. So if we add bromine water, remember that's brown or orangey, and we add it to an alkene, what's going to happen is those alkene arms will open up and grab onto this Br, so that will give us something that looks like this. So we have a Br on one carbon and we have a Br on the other carbon. Right, so this is called a haloalkane because it has a halogen. And because this is an unsaturated molecule, because that bonds open up quickly, this orange colour will go colourless very quick. And that's the difference between an alkane and an alkene. If we add bromine water to an alkene, that brown or orange will disappear within seconds. But with an alkane, remember we need UV light for an alkane to force one of the H's out because there's no room for this Br, but it forces an H out for one of the Brs to come and connect. Okay, so if we have a Br2, it looks like this, and it grabs onto whatever we give them. So if we have an alkene and we add an HBr or HCl or something with an H and a halogen, one of the carbons will grab onto the H and one of the carbons will grab onto the Br, forming a haloalkane again. Let's have a look at what else we could do. If we add water to it, and we add a little bit of acid to it just to kind of cut this double bond, so we're going to acidify it a little bit. What's going to happen is, because we've got H's, so this is made up of an H, H's, an H and an OH. Okay, so one carbon's going to grab onto the H and the other carbon is going to grab onto the OH. H and OH. And now what we call this is we've created an alcohol. So from an alkene we can create an alcohol. Then the next one, if we oxidize it, so remember we did redox and we worked with permanganate, remember that purple one that goes colourless? So if we add a permanganate that's acidified, if we add permanganate with this, what's going to happen is, though you don't have to worry about the mechanism and how that works, but it will add two OHs. So it forms a double alcohol, we call that a diol. And then if we add an alkene and another alkene together, those hands are going to open up. So instead of this carbon holding hands with this carbon, what's going to happen is it's going to open up, but because there's nothing else to bond to, it's going to grab onto this little molecule, and that would result in a long chain of carbons, and that is called a polymer. So look at the slime that we make, or that kids make at home. That is made up of long chains of these carbons linked together, and they are made by using these double bonds that open up, and because they can't, either going to close again or they can grab onto whatever is next to them. So that's the other molecule of alkene. So this is called a polymer, but we'll get into detail a bit later. So a quick recap, we talked about the family alkenes. They have a surname of "ene" at the end, so the same way that we name alkanes, but with an "ene" at the end. They look like this because they have a double bond, so we can identify them. Remember to write the number of where the double bond is on the molecule as well, part of this. So it might be, so for this one it's easy because it's only with one, so you don't necessarily have to write the number, but if it's longer, remember to write the number of the carbon that the double bond's on. They have low melting and boiling point because those molecular forces between those molecules are very weak, but the longer they are, the higher they get. Then it's insoluble in water because they are non-polar. Remember, non-polar, if you look at that, one side isn't more charged than the other one. They're pretty much similar, so they are non-polar. That's why they're insoluble in water, and then we call them unsaturated molecules because those molecules, although one of those bonds can easily open up to grab onto whatever we give them. And we looked at we can give them H2, so both of them could grab onto H's. We could give them Br2, so they grab onto Br2. We could give them water, so one will grab onto an H and the other one will grab onto the OH. And we can give them another alkene, so they grab onto each other to form a long polymer chain of alkanes.
Could this be that